Hello everyone, my name is Ashish Kapse and we are Group I6 from Vishwakarma Institute of Technology. We will be learning the topic virtual memory. The contents covered in this video will be as follows. What is virtual memory? Is it an hardware? No. Virtual memory is a feature of operating system. When a process to be executed is larger than the space in primary memory, that is RAM, virtual memory comes in play. It is a memory management system based on technique roll in and roll out. Let us see what it exactly means. Process to be executed is divided into smaller parts called pages, and the only required data or the only required page is extracted and stored in primary memory. The unnecessary data is kept in the secondary memory, that is hard disk. This is a fast process and the data in primary memory is altered at every instance. Why do we need virtual memory? First, limited physical memory. When a space in physical memory is limited, virtual memory helps us to do tasks with larger space requirement and helps us to do multiple programs simultaneously. Second, memory partitioning. This allows program to be divided into smaller unit called pages, which enables the efficient memory allocation. Process isolation. Each process has its own virtual address space, which can be accessed when required. Efficient memory utilization. Virtual memory extends the RAM and also boosts the program capacity.
So hello guys, my name is Ved and today I am going to explain you the concept of virtual memory. The virtual memory basically comprises of three parts: virtual address space, a page table and a page fault. A virtual address space refers to the set of all virtual addresses that a program can access as defined by the processor and operating system. The virtual address space is typically much larger than the available physical memory, and it allows multiple programs to share the same physical memory without interfering with each other. The operating system maps virtual addresses to physical addresses in memory using a page table, which is stored in the computer's memory and is used by the Memory Management Unit, which is also known as MMU, to perform address translation. This allows program to access more memory than is physically available and enables efficient management of memory resources in a virtual memory system. A page table is a data structure used by the operating system to keep track of the mapping between virtual addresses used by a program and the corresponding physical addresses where the data is actually stored. When a program running on the computer attempts to access a virtual address, the MMU consults the page table to determine the corresponding physical address where the data is actually stored. If the corresponding physical page is not currently in memory, this is known as a page fault. A page fault occurs when a page requests a page of memory that is not currently loaded in physical memory, either because it has not been accessed recently, or because there is not enough physical memory to hold all of the pages that are needed. When a page fault occurs, the operating system needs to load the requested page from disk into physical memory before it can be accessed by the program. So here we will see one of the demonstration of how virtual memory works. So this is a 12 gigabytes of RAM available in the in one of the operating system, which is also known as main memory. But the problem is the application or the program we want to run wants to use the 18 gigabytes of memory. So it can be divided in three parts of 6 gigabytes each, and only the required pages are invited or are drawn to the main memory to execute it, so it can be executed flawlessly. So next we are going to see address translation. Address translation is the process of converting a virtual address used by a program into a physical address where the data is actually stored in memory. The operating system uses a page table which maps virtual addresses to physical address to perform this translation. The page table stored in the computer's memory and is used by the MMU to translate this address. This allows programs to access more memory than is physically available and enables efficient management of memory resources in a virtual memory system.
In computer science, a page replacement algorithm is a method used by an operating system to decide which page in physical memory should be evicted when a new page needs to be loaded into memory. This is typically used in virtual memory system where not all of the program's data needs to be stored in physical memory at once. When a program requests a page that is not currently in physical memory, a page fault occurs. At this point, the operating system must choose which page to evict to make space for the new page. The choice of which page to evict can have a significant impact on the performance of the system. There are several different page replacement algorithms have been developed to solve this problem. Some of the most commonly used algorithms include least recently used or LRU, first in first out or FIFO, clock algorithm or second chance algorithm, and optimal page replacement. Now we will study about these types of algorithms in detail. The first is the least recently used or LRU. The LRU algorithm is based on the principle that the least recently used page is the most likely candidate for eviction. This algorithm requires keeping track of the timestamp of the last access for each page in the memory. When a page fault occurs, the page with the oldest timestamp is evicted. Implementing LRU can be expensive as it requires updating the timestamp of every page that is accessed. However, it has been shown to have good performance in practice. For example, suppose we have a system with 4 pages in memory A, B, C, and D. Initially, A, B, and C are loaded into memory in that order, and D is not yet in memory. When a process requests page D, a page fault occurs, and the operating system must choose which page to evict. If we are using LRU, the page that has not been accessed for the longest time would be evicted. If page B was last accessed the longest time ago, then it would be evicted and page D would be loaded into memory. The next is the first in first out or FIFO. The FIFO algorithm is a simple algorithm that works by evicting the page that was loaded into the memory first. The operating system keeps track of the order in which pages were loaded into memory and evicts the page that was loaded first when a page fault occurs. While FIFO is easy to implement, it can suffer from Beledi's anomaly. Beledi's anomaly is a phenomenon in page replacement algorithms where increasing the number of frames in physical memory can lead to an increase in the number of page faults rather than a decrease. For example, suppose we take the above example, but where we are using FIFO instead of LRU. If a page fault occurs when page D is requested, the page that was loaded first into memory, that is page A, would be evicted and page D would be loaded into memory. The third is the clock algorithm or the second chance algorithm. It is an improvement on FIFO that uses a circular buffer to store the pages in memory. It also uses a use bit to track of whether each page has been accessed since it was last considered for eviction. When a page fault occurs, the operating system scans through the circular buffer until it finds a page with a use bit set to 0. If no such page is found, it gives each page a second chance for setting its use bit to 0 and moving on to the next page in the buffer. This process continues until a page is found to evict. For example, taking the previous example, but we are using clock algorithm instead of FIFO. If a page fault occurs when page D is requested, the operating system would scan through the circular buffer of pages in memory until it finds a page with its use bit set to 0. If no such page is found, each page in memory would be given a second chance by setting its use bit to 0 and the scan would continue. Suppose page A has its use bit set to 0 when the scan reaches it. Then the page A would be evicted and page D would be loaded into memory. The last is the optimal page replacement. This is an ideal page replacement algorithm that works by evicting the page that will not be needed for the longest time in the future. While this algorithm provides optimal performance, it requires knowledge of the future page requests, which is generally not possible to obtain in practice. For example, suppose we have a system with 4 pages in memory A, B, C, and D, and following sequence of page requests occurs: A, B, C, D, E, F, G, H, I, and J. If are using the optimal algorithm, we would need to know the future page request to determine which page to evict. Suppose we know that the next page request will be E, F, G, H, I, and J in that order. We can then determine that pages A, B, and C will not be needed again until after all of these requests have been made. Therefore, the page that will not be needed for the longest time in the future is page A. So it would be evicted and page E would be loaded into memory. Each of these algorithms has its advantages and disadvantages, and the choice of which algorithm to use depends on the specific requirements of the system. LRU is generally considered to be a good all-ground algorithm that provides good performance in most situations, but it can be expensive to implement. FIFO is simple but can suffer the Belady's anomaly. The clock algorithm is an improvement on FIFO that provides good performance with lower overhead than LRU. Optimal is ideal but impractical in most situations.
Hello everyone, myself Sahil. I will be discussing some important concept in computer organization and architecture. My topic is virtual memory and storage. So first, let's talk about the virtual memory. Virtual memory is a technique that extend a computer RAM using disk storage. It allows program to use more memory than physical available, making it possible to run large application or multiple applications simultaneously. So virtual memory is used by the operating system to create a virtual address space for each process which is then mapped by physical memory. So next is the we have paging. So paging is the technique used to divide memory into fixed size page. So each page is continuous block of memory that can be easily allocated or deallocated. The advantages of the paging that is allow the operating system to manage memory more efficiently, as only the page that are needed by the program are loaded into the physical memory. So of the to keep track of the mapping between virtual and physical address, we have the page table. So page table is the data structure that map virtual address to physical address. It is used by the operating system to manage the translation of virtual memory to physical memory. So next is the when a program tries to access a page that is not currently in physical memory, so that page is default occur. So this trigger is operating system to replace a page in physical memory with the missing page from the disk storage. So next is the moving on to storage. We have non-volatile memory, which is the type of memory that retain the contents even when we power is turned off. Non-volatile memory is used for the data storage such as hard drives and solid state drive. So non-volatile memory store the programs. So finally we have caching. So caching is a technique used to store frequently accessible data in a faster or closer location at the processor. So this can be greatly improve performance by reducing the number of times data needed to be retrieved from slower memory or storage. So thank you. That's from my side.
So here are some advantages and disadvantages of virtual memory. First one is increased memory capacity. It allows program to access more memory than physically available. Next is memory isolation. In memory isolation, processes operate in separate virtual address spaces, enhancing stability and security. Next one is simplified memory management. It allows dynamic allocation of memory resources. In efficient demand paging, it loads data into memory as needed. It reduces load time and improve utilization. So here are some disadvantages of memory, virtual memory. So first one is performance impact. Accessing data from virtual memory is slower than accessing it from physical memory. It leads to potential performance degradation. Next is fragmentation. Virtual memory can suffer from fragmentation. Where free memory is divided into small blocks like non contiguous blocks, it reduces efficiency. Virtual memory may not fully exploit the potential performance benefits of directly accessing physical memory. It leads to limited physical memory access. So, this is also one of the disadvantages of virtual memory. Complex memory management is also one of the disadvantages of virtual memory.
So, in conclusion, I would like to say virtual memory plays a critical role in modern computer systems. As the demand for computing power continues to grow, the importance of virtual memory is only likely to increase in the years to come. That's from our side. Thank you for your attention. And I hope this presentation has provided you with a better understanding of virtual memory and its role in computer systems. If you have any questions or comments, I would be happy to address them. Thank you.
Thank you.